All right, well, what do you say? How about if we go
Yep.
ahead and get started? Okay.
Sounds good.
All right, good afternoon, everyone, and thanks for joining our educational session here this afternoon. Our topic is South Dakota's Next-Gen 911 GIS Data and Managed Services. I'm Shawnee Rechtenbaugh. I'm the State 911 Coordinator with the Department of Public Safety here in Pierre, and then I'm also staff for the State 911 Coordination Board. And myself and Ted Rufflett, the chair of the State 911 Coordination Board, are going to take just a few minutes here at the beginning to go through the first couple of slides, and then we're going to turn it over to the team from GEOCOM. So just quickly, a couple housekeeping items. This session is being recorded, so if you need to listen to it again at a later time, or if there was someone in your office that was unable to attend either today or tomorrow's session, we'll have a recording available. So keep that in mind. And then in order to keep background noise to a minimum, I'll ask that you just mute your phone line throughout the presentation. And let's see, and then also if you have questions as we go or at the end of the presentation, we're going to handle questions through the, by typing them in through the question box. And you should see over to the right of your screen a control panel, and that has a question box there where you can enter your questions in. So feel free at any time to do that. That way our presenters can kind of go through them and group like questions together, et cetera, or if they know a topic's coming up that's going to cover that question, then they can kind of work it in. So if you would use that for your questions, that would be wonderful. And so with that, I think we'll go to the agenda slide, which you should be seeing on your screen. First thing is introductions here in just a moment, and then the Next-Gen 911 in South Dakota, so kind of what's happening today and what we're doing. Then we'll have an overview of Next-Gen 911 and GIS. Then GIS data analysis and collections, followed by a question and answer time. So with that, I've introduced myself. You know who I am. And so I'd like to introduce the rest of our team for today's presentation. So first, I mentioned Ted Rufflett, but Ted, would you introduce yourself further?
Sure, thanks, Shawnee. Ted Rufflett, chair of the 911 board, and also, as most of you probably know, I'm with Bennington County 911 in Rapid City.
Thanks, Ted. And then next, I'll go over to Christy Hayes with GEOCOM.
Hi, thanks, Shawnee. This is Christy Hayes. I am the project manager from GEOCOM working with the South Dakota team on this project.
And Christy, do you want to introduce the rest of your team or lead that off?
Sure. Sean, do you want to introduce yourself? We've got two other team members with us today.
Okay.
Sean, are you on mute? Are you there?
Now I'm unmuted.
Sorry.
Hi, I'm Sean Lehman. I'm GIS project manager here at GEOCOM. I'll be working with our team here and with the state panel, and look forward to working on this project with everyone.
Thanks, Sean. And did you have one more, Christy?
We do. John. I show you unmuted, John. Are you there?
I'm just shooting him an IM.
Okay.
He's maybe stuck in mute land.
Can you hear me now?
Do need to.
There.
Yes, you can.
Yep.
We have a few questions.
gosh.
There is a number that you need to dial into with an access code. It should be in your control panel once you log in under audio.
I think I'm good to go now. You guys can hear me. I'm John. I'm the GIS data manager here at GEOCOM, and I'll be talking to you a little bit about the analysis and data collection here in a little bit.
Great.
Thank you. Okay, and so that's everybody, right, Christy? Okay. All right, so then if we can go ahead to the next slide, slide 3 here. This is just a little background on kind of what's happening in South Dakota. So today, the current legacy 911 system in South Dakota has served us well for many decades, certainly. However, really in the last 2 decades, we've seen extensive changes and advances to the way we communicate. And the legacy 911 system, was built on or built with telephone technologies from about the 1970s, and was originally built to handle landline phone calls, not cell phones, VoIP phones, and other communication devices that share data. Cell phones and other wireless communication devices have made it necessary to implement NextGen 911 technology in South Dakota. And the NextGen 911 system will really take us into the 21st century and allow our 911 centers to catch up with the current communication technology and keep pace with that technology as it continues to evolve. There's new things coming along all the time. So that's kind of the reason why we are doing this and why all of this has been happening in the last couple of years. And so right before Christmas, we signed a contract with Telecommunications Systems, or TCS, to build the new statewide NextGen 911 system. The 911 system is comprised of a centralized 911 phone system, and all 911 centers will migrate to that phone system. And then all 911 centers and the new phone system will then be linked by secure and redundant broadband connections. SCN Communications, which is based in Sioux Falls, is a subcontractor to TCS, and they'll be the broadband provider for the NextGen 911 system. The whole infrastructure upgrade will position all the 911 centers in South Dakota for many operational and technology advancements. Some will come right away, others in the near future, and many, many more down the road, certainly. And so now I would just pass it over to Ted for some additional information related to today's presentation.
Thanks, Shawnee. And as Shawnee said, I just want to add a couple things here about why we're here today and where we're going with this project. So in addition to the contract with TCS that Shawnee spoke of a minute ago, the 911 board has also contracted with GeoCom. They're out of St. Cloud, Minnesota, and I think a lot of you are probably familiar with GeoCom. They've been doing business in the state with different entities and PSAPs for a long time. But they're going to handle a lot of what they do is going to be supporting infrastructure that's in the background of the NextGen 911 system. And their first task is to gather 911 related GIS data from the various local sources around the state. And this is the same data that's being used by our 911 centers today locally. They're going to aggregate that data into a series of statewide map layers that will be used within the 911 system, the NextGen 911 system. Currently, every county has a 911 coordinator, and those 911 coordinators around the state add new streets and other 911 related information into the MSAG. This is currently maintained by Intrado and CenturyLink. When the NextGen 911 project is complete, your 911 coordinators and the local GIS support folks who support the PSAPs, instead of logging into that 911 net system and adding tabular data, you're going to be uploading your new roads and address points and changes to the MSAG. You're going to be doing it through the GIS data. You'll upload that data to GeoCom. And GeoCom will then quality check it, update the statewide system, and then push it over to TCS. TCS will use that data to make call routing decisions and support the system on the back end. Other 911 coordinator tasks like correcting customer names and phone numbers, again, when this is all done, that'll be done with TCS instead of Intrado. These changes are all part of the NextGen 911 project and are things that are coming. GeoCom is going to play a critical role in ensuring that the GIS data is always ready to support the live ng911 system that will be operated by TCS. I think most of you would probably agree that CenturyLink and Intrado have done a good job providing the legacy 911 system for us for many years. But as we move on to the next-gen system, TCS and GeoCom will be the providers of the 911 system, and you know, new faces and new people, and a big advance in technology, and so we're looking forward to that. We're very excited to get this project started and get these tasks underway. I want to thank you for taking the time to join us. Like Shawnee said, if you've got questions, you can type them in there, or you can contact Shawnee via email or phone later, and we'll be happy to get answers back to you. So now I think we're going to turn this back over to GeoComm and Christy to take us through the rest of the slides.
Great. Thanks, Ted. Okay. I want to spend just a couple minutes talking about GeoComm's role in South Dakota's Next Gen 911 project. Here is the goal for our project. We are going to assisting and providing the state of South Dakota with a complete end-to-end ng911 GIS solution. We're going to be including workflow development and implementing a single seamless gapless GIS data set that will be provisioned into the ECRF and LVF systems. We have a lot of steps that we need to do to get that accomplished. One of the things we're going to be doing, or that we're in the process of doing, is working with the South Dakota group on finalizing a statewide GIS data model. We're developing GIS maintenance workflows. A lot of what we're going to talk about today are the upcoming GIS data, county GIS data assessments, the reports that are being involved, and remediation that's going to be involved with that, and working on improving that data. And then we're also going to be providing training and giving a presentation on the final GIS workflows and how the system's going to work, how each of the counties can implement the system, be able to look at their data, make changes, etc. We plan on doing all of this and completing this implementation part of the project by December of this year. So we've got a lot of work to do, and we are really excited and looking forward to working with the counties and the state as well on this project. At this time, what we're going to do is give an overview on how GIS plays into Next Generation 911. So I'm going to turn it over to Sean and John at this time.
Great. Well, good afternoon, everyone. Again, this is Sean Lehman. This slide really, what we're going to talk about is just what Shawnee was just mentioning, that this current state of E911 moving towards this next generation. So right now, currently, calls are being plotted. Once they get into the PSAP, that information's plotted and used to find that 911, where that caller is coming from, where it's located, locating the different CAD incidents, used to the AVL, the automatic vehicle location functions, if it's available, and then trying to find if that closest unit, what's the closest unit to that incident. So for the GIS data that we're going to be using, which is coming from each one of the counties, in this type of environment, you need to have that data really good and standardized and synchronized to one another, just so if there is an issue that comes up and a dispatcher is not able to find it, now they're having to do a little more investigative work to locate that call. So with the current state of the GIS data, again, once it's pushed in even to the CAD systems, into that CAD map now is static to what the latest information that was pushed into it. So as we move towards this next generation 911, what's interesting is that now we're going to be able to route that call to the PSAP based on the GIS information. So again, with the GIS data being synchronized and standardized to one another, it's going to be very critical to have that information. And then now, as far as the frequency of the updates of the GIS data versus the traditional this E911, in the E911 environment, maybe the data is pushed into a map, but then there's no updates to that data. Maybe working with your CAD vendor, it gets pushed in every quarter, maybe every 6 months. But what about those new subdivisions, that might come in? We want to make sure that that information is up to date. So in this new environment, again, for the statewide Next Gen 911, all this is going to be into a seamless environment. That call is going to be validated up front. And now having this data together, it's going to get us to that next environment to have this state database.
Great.
You can go on to the next one.
Okay.
So really, how does it come together? You know, what is this EZNet, this big cloud environment? Well, it really is an IP-based network. It's definitely more robust than the traditional kind of the ng911 landline. It provides more information, such as video, text information will be passed along. And in this environment, it's definitely more robust since it is in the cloud. And then for here we're starting off is we have our subscribers, we have our communication service provider. This information is going to be stored in this location information server. So all the addressing information is going to be stored in the server. It's going to go through this function where this green box really represents your GIS data. And this is where the GIS data is going to come into play. And so what this information server with all the subscriber information is going to validate to your GIS data. We're going to know up front if it's yes, it validates, no, it doesn't. Now all this location information is now stored, and this is all the pre-call kind of behind-the-scenes information. So now when the actual call comes in, that location is sent with the call, and it goes through this border control function, and then gets passed on to this routing proxy. Again, that information, that location is now tapping into this data in this ECRF function, where it's validating that incident, it's plotting it on a map, and it's determining which boundary, which PSAP that call belongs to, and then this now gets pushed back to that PSAP, where again you have green boxes here where you have that map display, which you're probably used to seeing is that map in front of a dispatcher at the call center. So that, like I said, that call location information is then mapped in the application. So how is this data going to be updated? Again, we're sitting here. It's going to be pushed up into a statewide seamless data set for the address points, the road center lines, the emergency and the admin boundaries, along with the cell towers and the cell sectors. All this is going to be seamless. It's going to be pushed. We're going to have this functionality, the spatial information function. This is going to allow for updates, to run quality control checks, to make sure that that data is consistent. Again, you have that new subdivision that comes in. It will get pushed up with these new addresses that can be pushed into the system. And now this master statewide database is now going to be available as this data provisioner, so the data is going to be up to date.
Great.
And then again, this is just kind of another big picture. Again, these are just all IP-based calls in this cloud network. There's going to be a lot of this information is going to come in. It's going to be plotted on a map. That information then gets passed along to the PSAP along with this additional information. I know we're throwing a lot of acronyms out there, but the SIP is another packaging of the call, the text information, video, pictures. All that information is going to be passed along to the PSAP.
So this is John Kraft, and I'm going to go over a little bit about the analysis and what we need from you and what the analysis is. And before I get started on this, this is usually one of the more touchy subjects, at least in past projects that I've worked on. A lot of people are very have a personal connection with their GIS data, and when they hear the word analysis, they often think, oh my gosh, they're going to give me a report card. Am I going to get an A, a B, a C, a D, or am I going to fail? You know. And so the purpose of the analysis that we're going to do is not really to identify that you have bad data or good data or where it ranks. It's really to just identify gaps in the data that need to be looked at and corrected or accepted as an anomaly in the data before it's pushed into that statewide data set. And the purpose of this is to make sure that everything is standardized, you know, in a similar fashion, and that all the data is going to kind of match. And so we do this initial gap analysis to ensure all of that's going to be happening. Some of the layers that we need for this gap analysis are going to be your GIS data, and I'll talk about the various layers here in a moment. Also, the MSAG and the ALI database are going to be used to verify that, you know, all those address points or address records in the ALI are represented. Every block range from that MSAG is represented. Where it's not, we'll kind of call it out. We're going to perform these gap analyses on each county. So every county is going to be submitting their data, we hope, and that we'll do those gap analysis on. And that gap analysis is really going to be your guideline in terms of where the gaps are in your data that we found that need to be looked at, corrected, or at least flagged that, you know, this is an anomaly in the data. There's nothing we can do to fix it, even though it's inconsistent. It is the way it's supposed to be. So that gap analysis is going to be kind of like your roadmap on how to get to that statewide data set for your individual county. We're also going to do a statewide GIS data set analysis, and this is going to kind of happen a little bit later down the road, but what we're going to do is we're going to look at all of these countywide data sets in a statewide kind of schema, and we're going to look to see if there's any discrepancies between the counties. Say, for example, a topology error. There could be roadways that connect between maybe Potter and Dewey County that are not snapped and connected properly. So we're going to flag those and say, hey, you know, these really should be stitched at the same intersection point, so that way, you know, the intersection exists or routing can go back and forth between various counties. So we're going to do that statewide GIS data set analysis as well. We're also going to be doing results reporting. So the analysis, we put together this report, like I mentioned, and it's going to basically come back and it's going to outline all of that stuff. As I said, it'll be a roadmap to how you can get your data to that statewide level that we need it to be. So that's kind of a high-level overview of the analysis. Let's talk a little bit about the data that we're going to need on the next slide here.
I do have one question, John, that regarding results reporting. The question came in, it says, one data analysis report per county. What if a city spans 2 counties and the city is the authority for its geographical area in both counties? Will that entail a separate report, or would the city receive 2 reports?
Right. So my assumption is that the county would, probably both counties would have that data overlapping. So I don't know which city this would be, but I threw out the names Potter and Dewey a little bit ago. Let's say there was a city on the boundary right there. My assumption would be that Potter County would contain all of that data as well as Dewey. Correct me if I'm wrong, but would the city data be split in half, or would it be in a whole, even though it's outside of that county boundary? So the answer would be, you know, when you submit that data to us at that county level, it's okay for some of your segments and stuff to spill over into other counties. I fully expect that will happen. What I'm going to do an analysis on is that data you submitted to me. You know, to an extent, if the data is spilling out, you know, 5 counties over, I might call you up and ask you to clip it or something. But if not, you know, we'll do the analysis on what you send to us, and then we'll send it back.
Okay.
I hope that answers the question.
They added the comment, the city data is whole and the counties are cut at the city.
Okay. So the city then is going to be providing us their data as well. That's fine. We can do a gap analysis on that city data.
Okay. And one last question on this before we go to the next slide. We have a question, does this include reservations?
Yeah, so I think that was kind of a question we identified when we were on site maybe a few weeks back. Were all of the reservations going to be participating in this, Ted? I can't recall what the answer was on that.
Right. So the 911 board contacted all the reservations some time ago and invited them to participate, and to the best of our knowledge, none of them are participating. At least they haven't contacted us. We would certainly like to have their data and include it, and if we don't get the data from them, then we will obtain it from other sources so that we don't have big gaps in a state coverage map. DOT's got roadmaps, and we'll fill it in as we need to. But we certainly would like to get the data if they have it, and if not, then we'll go to other sources to fill those areas in.
Great, thank you.
Any other questions on that prior slide there?
That's all I've got right now.
Okay, cool. Yeah, I appreciate the questions coming in too. Usually, if we do this on site or something, it's an open dialogue. With this many people, that would be hard to do. But keep typing them in if you have questions as we go. So for the data analysis, some of the QA, QC checks that we're going to do involve various data sets. That first bullet there is address point data consistency and completeness. We're going to look at the point data, the site structure points, to ensure all the attributes that are mandatory are populated and are in place. So for example, does the site have a valid address point number? Does it have a valid name? Is that name standardized to specific standards that the state is going to be using? So for example, we would want to ensure that if you're using AVE for avenue, that it's consistent throughout that data set. So we're going to be looking at those points to ensure that they're consistent and they're complete. So that's, for example, one of the checks that we would do. So address point data is kind of a great thing. And if you don't have address point data, perhaps you have parcel data where we can create you can create a parcel centroid and use that as a starting point. So various ways to get there. We're also going to compare those address points to the road center line. So, and we do that in kind of a two-part phase. We look at it from the address points compared to the roads, and then we also look at the roads compared to the points. So we look at it frontwards and backwards to find any inconsistencies in the data. We want to make sure that that address number on the point is contained in the range of the center line and that it's on the correct side of the street. So every street's going to probably have dual ranging where you have one side with odd addressing and one side with even addressing. That's in an ideal world. So we'd want to make sure that that address point falls on the correct side of the street, that it is within the range of the street center line, that the naming of the address point matches the naming of the center line, that the city values are the same and consistent, and that everything's populated. So we really look at it in both ways there to make sure that those matches and those consistencies and those standards are being met and followed. Just like with the address point consistency and completeness, we do the same thing with road center lines. Standardizing the data, AVE, once again, avenue, it's really important to make sure that everything is consistent on the statewide level. And the purpose of that is just for completeness, consistency, to make sure that you don't have a variety of different standards that are being used. We're kind of striving for NENA standards, and NENA is using the USPS street type suffixes. So you can kind of look at that and get an idea for what is being called out and what's being required. Road centerline address range check. We're going to look at these center lines to ensure that the address ranges are complete. And how do we do that? Well, there's a number of different QA, QC checks we do. One of them is going to be looking at the parity or the odd and even consistency of these streets. We want to make sure that every segment of that street is consistent in terms of odd addressing on one side and even on the other. And there are going to be cases or instances where that's not the case. You know, maybe they have consecutive addressing on one side of the street in a mobile home park or something like that. And that's okay. We're going to call it out and say, hey, this could possibly be an error. But one of the workflows that we'll go over is this kind of geocom exceptions field that you can flag those. It's a known exception that, you know, even though it doesn't follow the typical addressing authority rules, there's nothing we can do about it. It is what it is, and we're going to flag that as okay. So there's various ways you can flag that data, but it'll come back to you in that analysis report that, hey, this is something you might want to look at. In addition to parity, we're also going to be looking at completeness. We want to make sure there's no overlapping ranges. This is probably one of the more critical, I would say, issues with centerline data is if you have multiple streets with the same range, same name, same zone. If a call comes in and it hits more than one segment, how do you know where to dispatch that call to? So we're going to run an analysis on that and flag all of those overlapping address ranges that exist in the data as well, and those should really be looked at and corrected. We're also going to look at the address ranges in terms of duplicating ranges between counties. So let's say you have some county streets that spill over from one county to the next and vice versa. We'd want to make sure that we look at that as well and kind of call those out and maybe create some stitch points where folks can snap their center lines to each other at those county boundaries. So address ranges are very important in the CAD system and in mapping. Topology checks are another big one we're going to look at. We'd want to make sure that the topology is clean across the data set. So, you know, if you have center lines that are not snapped at intersections, if you have center lines that just are not following general topology rules, we'll call those out as well. The next bullet there talks about boundaries, and I'm going to kind of go back and forth here on topology and boundaries between streets and the boundaries. And one of the main things is we'd want to make sure that all the streets are split at boundaries, that it's not, you know, existing in two different boundaries. And the reason being is if I have a left and a right center line value for a boundary assignment and that center line exists in two boundaries, how do you know which one to assign it to? So in terms of topology checks, that would be another check. But boundary layer and consistency and completeness is another big one. We'd want to make sure that all of the boundaries are seamless. There's no gaps in the boundaries or slivers. There's no overlaps between boundaries as well. And that where the boundary is following a center line, it really should be edge matched to those center lines unless there's a right-of-way to ensure that those boundaries are consistent and complete. Also, the attributes in those boundary layers, we'd want to make sure that all of the critical fields in that boundary layer are populated, so you know exactly what that boundary is. There's a multitude of QA/QC checks that we do for this gap analysis, and you know this is very high level, just one of them, but or some examples of them. But overall, it's a pretty good report, and it'll give you that good roadmap of where you're going. Any questions on that slide there?
Did not receive any.
Great. So let's move on to the next one. This next slide is kind of just a nice screenshot of where the data might come from. So on the left-hand side, we have these GIS sources. There's the local 911 authorities. They might have some data to send over, address authorities for change requests, other authoritative boundaries, so whether that's you know, paper maps or something else coming through. So there's various ways that this data exists. And so what you'd want to do is get that data. We're going to send it over. It'll be QA'd. It'll be converted into you know, all the same projections and stuff, and kind of coalesced into this statewide GIS data set, at which point then it would be staged in the ECRF, the LVF, and the PSAP mapping servers. So really it's kind of taking it from the sources, that county source or a city source, and then coalescing it all into that statewide data set. And one of the ways that that's going to happen is there's going to be a statewide data model, an approved statewide data model, which is currently in the works. And when you submit that data over, there's going to be a field mapping component to it, where you're basically going to say, hey, my field for, you know, street name is called name. The statewide schema is called street name. You know, the data from my field really goes into the data of that field. So there's going to be a field mapping component of it to ensure that all of your data, when it's coalesced into that statewide data set, it goes into the appropriate fields and you know exactly where that data is going. So that's kind of a big key piece of this as well. And then if we move on to the next slide, any questions on that one?
No.
Okay, great. So GIS data collection, what are we looking for? Obviously road center lines, that's a big piece of this. We'd want to make sure we get road center lines. It's important that you have the ranging on those center lines done, all the naming attributes, stuff like that. The service area polygons, so fire, law, EMS, those are always good polygons to have. If you have city boundaries, that's awesome. You know, maybe you have an accurate zip code boundary. Any of that data is great. We'd love to have all of that as well. PSAP boundaries, whether those exist or not, those are things that we'll be discussing and needing. Authoritative boundaries, site structure points. Once again, if you don't have an actual address point layer, parcel centroids would work, and then we can kind of go from there. Road name alias. So sometimes folks have the road name aliases embedded into the road center line. If that's the case, then you're not going to have a tabular data set. But if you do have a tabular data set, we would request that as well. And we're going to talk briefly about unique IDs here in a second, just kind of relating to that. Also county boundaries and municipal boundaries, so these are just some of the data collections that we would like to receive, in addition to the tabular data sets, which Ted, I believe you're working on the MSAG and the ALI database. I think we already have current MSAG, but so these are the various data collections that we'd be going for. I mentioned unique IDs, and I'm going to talk about this briefly before we move to the next slide. And I'm putting together a document to send out. So every feature class has a unique ID, whether it's the object ID or something you're manually maintaining. And one thing we're going to request is a unique ID other than the object ID. And the purpose of that is if you copy and paste your data from one place to another, the object ID can often change. So we would really want to make sure that there's a static unique ID for each feature that you're sending over. And the purpose of that is, say for example, we have a road name alias table, and that alias record in there joins up to the road center lines. We'd want to make sure that the link between those is going to be static. And so I'm going to be sending out a document talking about unique IDs and one method for creating them. You might already have your existing unique IDs that are static for your feature classes. If so, that's awesome. You can go ahead and use them. If not, then you can use this document to possibly populate those and learn how to manage them as you move forward. But unique IDs are going to be an important one as well. Let's move on to the next slide here. So one of the things that we're going to be providing is this data managed services, web DMS is what it's called. And this is going to be kind of highlighted really high level right now. We're going to talk more about this later on in the project, but early, or actually later in the year, we're going to be doing a couple go-to meetings for remote participation, and we're going to do hour sessions, and it's going to walk you through on this kind of tool set that we have where you can use it to manage and maintain your data moving forward in the project. So I would expect probably, I think we're talking early November for those trainings to pop up. We would ideally try to get it before that Thanksgiving break. I know a lot of people do vacations and stuff like that, but we'll probably do it early November and kind of go over this web DMS toolbar, change requests, and the GeoLink server training. And then on this next slide, we talk a little bit about wireless cell sectors. So I've received pretty much a lot of cell sectors from, I think, Ted, you got those from Intrado, right? Yeah. I believe so.
Yeah, sorry about that. The wireless cell sectors we've got, the statewide MSAG we've got, and the statewide ESN list we got. And you should have it now too.
Correct, yeah. So these layers are going to basically go into developing that statewide cell sector development, and then if there's any additional data coming in, we would kind of, same thing, coalesce that into a statewide layer for mapping purposes. So I think that's about all on that one.
Right. Okay. What most people are probably asking are, okay, when do we need to be working on this, and what are the key dates, and what am I responsible for? And I kind of just wanted to take a moment to go through a few of the things that we're going to need assistance from the counties. We talked a lot about gathering the data, and our goal is to gather county data to begin working on the assessments that John and Sean had mentioned by January 20th. What we're doing right now, we're in the final process of finalizing the contact list that we have for the counties to obtain the data from, and those contacts will be receiving emails with upload instructions from us on how to get their data uploaded to our ShareFile site so we're able to begin the assessments. Once that is done, we're going to give the reports to the counties, provide the reports to the counties, and there's going to be some time for remediation to go through all of the issues that are listed in the reports, and also be available to have a call with a county if they want to go through their assessment. We'll be available for that. We expect that to happen early May through the end of July. Once everybody's had a chance to work through the analysis and do the remediation work that's needed, we're going to do another assessment. So we're going to ask for GIS data again, and once we have all that data from everybody, we're going to compile it into a larger report and then provide that to the state. We're going to, at that time, also do the trainings that John had mentioned in early November. And then in early December, we're going to push the statewide data set out into the system for all counties to be able to have access to. So what's going to be needed from the counties going forward, if there are changes, that's going to be, those can be submitted as an ad needed, and we see that being an ongoing basis to be able to support the next gen system. Does anybody have any questions? Okay. I think we're at the end. Shawnee or Ted, I didn't know if you had anything else you wanted to add.
Shawnee, do you?
I don't. I've just been following along and listening so far. So, yeah, just thankful for the questions that are coming in, and if there's more, ask away, folks.
Yeah, same here. I think these educational sessions at this point in the project, kind of at the beginning, are critical, and I'm very happy with the information that's been presented, and hopefully if there's more questions, you folks don't hesitate to get them to us so we can get answers out there. And we're doing another one of these Thursday, I think. And,
yes.
No,
and,
or wait, yeah, that's tomorrow, right?
Or tomorrow, yeah.
Yeah, tomorrow's Thursday. I was thinking, no, it's tomorrow, but it is Thursday. Yeah. Tomorrow, sorry.
So no, I don't have anything else. So thank you, folks at GeoCom, for the information, and it's been a good session.
Great. And we will make this, as Shani mentioned, we will make this presentation available, as well as the questions that have asked. We'll supply answers to those as well. So I don't see any other questions coming through at this time. So
very good.
I don't know if we want to conclude the webinar.
Yeah, let's wrap it up, and
we sure can.
We'll do it again tomorrow.
Great. Thank you very much, everyone.
Good.
Thanks, everybody.
Yes, thank you. Bye-bye.